Another check we can carry out on the purity of our product is to look at it under thin layer chromatography. Here we've got some thin layer silica plates with a UV fluorescent indicator at 254 nanometers, which means if you irradiate the plate with short wavelength UV, they fluoresce with a bright yellow colour. But to see that, we need to turn out the lights. Must wear gloves and UV absorbing goggles for this, but you can see there that the plate is irradiated with light, and it's fluorescing bright yellow. Well, we've got two plates on which we've spotted samples. Here they are at two different concentrations. The one on the left is a much lower concentration than the one on the right. We've got from left to right in each case a sample of commercial aspirin. That's the first sample on the left. In the middle, the sample of product that we've made, and on the right hand side 2-hydroxybenzoic acid or salicylic acid. So we're now going to run those in a solvent system of methanol water, 9 parts methanol to 1 part water, 9 to 1 then, 9 parts water to 1 part methanol, and we should be able to fit 2 plates into the beaker at the same time. We'll turn off the UV light because it's rather dangerous and we don't need it whilst we're eluting the plates. So in goes the second plate, and we'll come back and have a look at those once they've got within the solvent's run through, within a centimetre of the top. Now that the plates have run a centimetre or two, or the solvent has run a centimetre or two from the top of the plate, let's take them out and have a look. So we need to lift out the plate carefully, quickly trace the line of the solvent front, and then dry the plate. Well, in fact we can dry them both together to save time. So again, trace the solvent front carefully in case we need to make any measurements. Remove the beaker with the water methanol mixture, and now we can dry the plates. Now what we need to do is to look at the plates under the short wavelength UV, and again we need to first turn out the main light. Now we turn on the short wavelength UV, and you can see we have 2 plates here. This is the plate with the lower sample amount. I'll show it behind the light there, like the lower sample amount, and you should be able to see that the product spot in the middle here, giving a circle, is the same as the commercial aspirin on the left hand side, but the salicylic acid, the 2-hydroxybenzoic acid, showing this long streaky spot here, so that's under the lower sample here. If we look at the higher sample, we've got again the same spot pattern. So here in the center, this is our product. On the left hand side, this is the commercial aspirin, and here this is the salicylic acid starting material on the right hand side. So the TLC gives some evidence for not only the conversion of the salicylic acid to aspirin, the 2-acetoxy salicylic acid, but also for the purity of the product there. We see nothing on this plate using this technique in the way. So that confirms the purity from the melting point, and we have indeed produced some aspirin. All we've got to find out now is what yield did we get. So the final stage of our experiment is to look at the yield of our product. So we'll start by weighing the empty weighing boat here, 2.57 grams, but we can weigh onto the balance, so we'll read 0. So here's our product. Remember, we started with 3 grams of salicylic acid, 2-hydroxybenzoic acid, and now the moment of truth. Well, we've got 0.95 grams of product there, so you should be able to work out a percentage yield. We started with 3 grams of salicylic acid, reacted that with an excess of ethanoic anhydride, and we've produced 0.95 grams of purified product. It should also be said that we've got a considerable amount of products here still in the filtrate from the initial filtration of our purified product, and that just shows the hazard of rushing to crystallize in a school chemistry lesson. Perhaps best crystallizing one lesson and filtering the next. That's the preparation of aspirin.